Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to learn algebra. Today is our lesson number 99. Lesson number 99, day number 99. Starting from day number 86 through 100 until tomorrow, we have been doing problems on the concept of linear equations. Today is our penultimate day on the subject. Our penultimate day, our second to the last day. If you want to learn this word properly, just type in the tag Keshwani Prep-vocab-day 11 and you will see the vocabulary videos that I have on the YouTube where you can work on your vocabulary in addition to working on your math skill. Day number 99. Let's see what we have for today. As I said, our penultimate day on the subject, because tomorrow is day number 100, is the last day. Starting from day after tomorrow on day number 101, I'm going to begin solving word problem. I'm going to do 100 word problem from day number 101 through 200. I hope that's going to be plenty of exercise for you. Let's see what we have for today. 4/3 x plus 5 plus 5/2 x minus 2. We are told that that is equal to 5x minus 3. Again, I'm going to read it one more time to you. And at this point, after taking the question down, if you want to pause the video, solve the problem yourself, and then you can resume it and compare the work that you did yourself, the answer that you arrive on your own, with the work that you and I are going to do together. Here's the problem: 4/3 x plus 5 plus 5/2 x minus 2 equals 5x minus 3. First thing first, we have to have common denominator. This term has a denominator of 3, this term has a denominator of 2, and this term here, the way it sits here, it has a denominator of 1. We do not have common denominator. We need to have common denominator before we can do anything. What would be the common denominator of 3, 2, and 1? It will be 6. How do we convert this 3 into a 6? Well, multiply the top and the bottom by 2. Now we have a 6. 2 times 3 is 6. How do we convert this denominator of 2 into 6? Well, multiply the top and the bottom by 3. How do we convert this denominator of 1 into 6? Well, very simple. Multiply the top and the bottom by 6. There we go. Now we have the same denominator of 6. We don't have to worry about it. We can simply ignore it. For example, if somebody asks you 30 divided by 6 minus 18 divided by 6, would you agree that that quantity is true, that this equation is valid? Well, let's see. 30 divided by 6 is 5. 18 divided by 6 is 3. 5 minus 3 equals 2. That's a valid equation. But this has a denominator of 6. This has a denominator of 6. This has a denominator of 1. It is a very fact. It is a very fact that here we have a denominator of 1, not 6, which is precisely why we cannot ignore this 6. We have to talk about this thing as 30 over 6. 18 over 6. This 6 cannot be ignored because the denominator is different. Had the denominator been same throughout the entire equation, we could have just ignored 6. How do we make this denominator of 1 into a 6? Multiply the top and the bottom by 6. Well, now we have a denominator of 1 times 6, which is 6. Now that we have the same denominator under each term throughout the entire equation, this 6 has ceased to play any role. It has ceased its significance. It has lost its significance. We can simply ignore it. We can simply ignore it and the equation would still be valid. 30 minus 18 equals 2 times 6. You see? That's what's going on here. We have a denominator of 6 here, we have a denominator of 6 here, we have a denominator of 6 here. We can ignore it. So, here we have 2 times 4, which is 8, times x plus 5. Then we have 3 times 5, which is 15, times x minus 2. And then here we have 6 times 5x minus 3. Let's do it out. Let's do our thing. 8 times x is 8x. 8 times 5 is 40. 15 times x is 15x. And then here we have a positive 15 and a negative 2. A positive 15 and a negative 2 is going to give us negative 30. Because positive times negative times negative, it gives us negative. Equals 6 times 5, which is 30x. And then again, this is a positive 6, a positive 6, a positive 6, and a negative 3. A positive times negative is negative. We get negative 18. Now we have to combine the like terms. We have to combine all of our like terms. Here's the 8x, here's the 15x. Well, we know 15x, we know that 15 plus 10 equals 25. Therefore 15 plus 8 must equal 23. 23x, 40, a positive 40, and a negative 30 gives us positive 10. Now this equation is getting kind of weird because it's getting too crowded on this side and very spread out here. And technically my teachers will tell me that this equal sign should line up here, but I'm going to violate this thing so we can write it properly. Instead of erasing it and then wondering what it was, let's put it here. 23x plus 10 equals 30x minus 18. It is not quite as crowded now. We're going to do two steps and we're going to do them together. First thing first, let's bring this 23x. Let's bring this 23x on this side. Subtract 23x from here. Subtract 23x from here. This is a positive 23. This is a negative 23. The 23x is cancelled out. And then, so we have brought the 23x to this side. Let's bring the 18 to this side. Let's add 18 to both sides. Negative 18 and positive 18 will cancel out. And we'll end up with 10 plus 18, which is 28. And 30 minus 23x is 7x. We need to get rid of the 7 from the bottom. We need to get rid of the 7, the coefficient. Divide both sides of the equation by 7. Now at this time, we're going to bring the x to this side of the equation, to left side of the equation, to honor the tradition. The tradition is, the convention is, the norm is, the custom is that one puts the unknowns if there are more than one, in this case there's only x, on the left hand side and all the known quantities on the right hand side. So let's switch the slide now. 7 divided by 7 is gone, so x equals 28 divided by 7, which is 4. Voila, that's our answer. X equals 4. We're not quite done yet, because we need to establish, we need to ascertain whether or not this guy is a real McCoy. Yeah, real McCoy. See if it's the real thing, see if it fits. We need to put this value of x back in the equation and see if it fits, see if it satisfies the equation. Let's do that, shall we? In order for us to do that part, it will be much simpler if we leave the equation in its original form. Take out all the things that we had added. Take out all the things that we had added to it and leave it in its original form and see what happens. let's start from this side here. This is a 5. 5x. X is 4. X is 4. 5 times 4 is 20. 20 minus 3 is 17. So we get 17 here. This thing better boils down to 17. Let's find out. X is 4. 4 plus 5 is 9. So it's 4/3 times 9. Well, 4/3 times 9, this part is 9. 4 plus 5 gives us the 9 part right here. And this 9 will cancel out with this 3, giving us a 3. So this entire thing is 12. 4 times 3 is 12. Again, x equals 4. Let's put it in here. 4 minus 2 is 2. This is very simple. This is just 5 over 2 times 2. And the 2 will cancel out. And we have a plus sign in the middle, right here. So this is 12. 4 times 3 is 12. 12 plus 5 is 17. What do you know? 12. 12, you see, 4 times 3 is 12. Plus a 5 equals 17. It fits. It works. Everything is fine. That's it. Today was our day number 99, our penultimate day, second to the last day on the topic of linear equations. We've been at it for now 15 days. Today was our actually 14th day. Tomorrow is going to be our 15th and the last day on the topic. And starting from day number 101, we will begin to solve word problems. We will do 100 examples of word problems for 100 days from day number 101 through 200. Okay, it's a long journey, but we'll arrive there one day. Okay? But you have to put in the work, you have to put in the effort, you have to put in the time. That is the only way that one learns anything. If you want to learn the algebra, there is no other way. This is it. I'll see you tomorrow. I'm done with my sermon. I'll see you tomorrow on day number 100. Okay?